Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hazim bin Zulkifli and my number matrix is 10DTP22F1008.
My name is Muhammad Afif Fikri bin Muhammad Azim and number batik card is 10GTP22F1002.
Introduction of the process. Electrochemical processes often involve chemical reactions that occur at the interface between an electrode and electrolyte solution. In this combined process, chemical reactions take place to produce or consume electrons, which are then transferred through an external circuit, generating electrical energy. This integrated electrochemical process is fundamental in technologies like batteries, where chemical reaction within the cell produce electrical energy, or in electrolysis, where electrical energy drives chemical transformations. Principle of operation. What are electrochemical principles? On the principle of a redox reaction, an electrochemical reaction works. Redox reaction stands for the reduction-oxidation process. With a fast redox reaction, an electric current is produced in the form that a chemical change releases the energy. An electrochemical cell has two half parts, and each half has an electrode and electrolyte. The components of electrochemical cells are electrode, anode, cathode, electrolyte, salt bridge. In electrolytic cells, to force an electrochemical oxidation-reduction reaction, electrons in an electric current are intentionally pumped through chemicals in cells. In voltaic or galvanic cells, these chemicals are deliberately taken outside the cell to flow through the electronic circuit to operate the electric device. In an electrolytic cell, to form the electricity, a chemical reaction is produced vice versa. In a voltaic cell, to form chemical reaction, electricity is produced. Machine parts and components. First, surface treatment. Parts may undergo chemical processes like electroplating or chemical etching to improve corrosion resistance, enhance surface hardness, or add aesthetic finishes. 2. Corrosion protection. Electrochemical processes such as cathodic protection are used to prevent corrosion of metal components by applying a sacrificial anode or impressing a direct current to counteract oxidation. 3. Battery systems. Components like electrodes and electrolytes in batteries undergo electrochemical processes during charge and discharge cycles, converting chemical energy into electrical energy. 4. Metal fabrication. Chemical processes like electroforming can be used to fabricate intricate metal parts by depositing metal ions onto a conductive surface. 5. Cleaning and degreasing. Chemical processes involving solvents or alkaline solutions may be used to clean machine parts, removing contaminants like grease and oil. 6. Material synthesis. Chemical processes such as polymerization or alloying are used to create materials for manufacturing machine components with specific properties like strength, flexibility, or heat resistance.
Machining, or ECM, is a method of removing metal by an electrochemical process. It is normally used for mass production and is used for machining extremely hard materials or materials that are difficult to machine using conventional methods. Its use is limited to electrically conductive materials. This video will cover the following about electrochemical machining process. 1. Working principle. 2. Construction. 3. Working. 4. Applications. 5. Advantages and disadvantages. Working principle. Whenever the two electrodes, anode which is connected to positive terminal and cathode which is connected to negative terminal, is immersed in an electrolyte, such as NaCl. When the voltage is applied across the two electrodes, the material removal from the anode starts. The anode and cathode is placed very close to each other without touching. In ECM, the material removal takes place at atomic level, so it produces a mirror finish surface. ECM working is opposite to the electrochemical or galvanic coating or deposition process. Let us understand the chemical reaction taking place in this process. As the potential difference is applied across the electrode, the movement of ions starts in between the tool and workpiece. The positive ions moves towards the tool and negative ions move towards the workpiece. At cathode, the hydrogen ions takes electrons and gets converted into hydrogen gas. In the same way the iron atoms comes out from the anode which is workpiece as Fe++ ions. Within the electrolyte, the sodium ions combines with hydroxyl ions and form sodium hydroxide, and ferrous ion combine with chloride ions and forms ferrous chloride. Also iron ions combine with hydroxyl ions and form iron hydroxide. In the electrolyte, the FeCl2 and FeO2 produced and gets precipitated in the form of sludge and settle down. In this way, the material is removed from the workpiece as sludge. The various reactions taking place in the electrochemical machining process are as follows. Construction. Electrochemical machining setup consists of following parts. Power supply. It requires a DC power supply for machining purpose. Electrolyte. The electrolyte has three main roles in the ECM process. It carries the current between the tool and the workpiece. It removes the products of the reaction from the internal electrode gap, and it removes the heat produced from the passage of the current. Tool. Tool is a replica of the shape required on the workpiece. Tank. This holds the electrolyte in which the tool and workpiece are immersed. Workpiece. Workpiece holding table. Pressure gauge. It shows the pressure at which the electrolyte is supplied to the tool. Flow meter. It shows the rate of flow of electrolyte to the machining area. Flow control valve. This helps in controlling the rate of flow of electrolyte. Pressure relief valve. In case the pressure in the supply lines increase, this pressure relief valve opens and bypasses the electrolyte to the tank. Pump. Pump helps in circulating the electrolyte. Reservoir tank. Stores the electrolyte. Filter. It helps in filtering the impurities present in the electrolyte which may chock the supply lines. Centrifuge. It helps in separating the slug from the electrolyte. Slug container. Stores the slug produced during the machining process. Working of electrochemical machining. First, the workpiece is assembled in the fixture and the tool is brought close to the workpiece. The tool and workpiece is immersed in a suitable electrolyte. After that, a potential difference is applied across the workpiece, which is anode, and tool, which is cathode. The removal of material starts. The material is removed in the same manner as we have discussed in the working principle. Tool feed system advances the tool towards the workpiece and all.
Application of chemical and electrochemical process. First, at aerospace industry, chemical machining process are used for manufacturing intricate parts like turbine blade and engine component. Second, medical device manufacturing. Electrochemical machining is used for creating intricate shape in medical instrument. Third, electronic industry. Chemical etching is used in the electronic industry for producing, printing, circuit board, component, transmission part, and full system component. Fourth, tool and die making. Electrochemical machining is used in tool and die making for producing high processing tools. Next, jewel making. Chemical etching is used in the jewel industry for creating intricate design on on metal surface. Next, macrofabrication. Chemical and electrochemical machining process are used in macrofabrication for producing macroelectrochemical system, macrofluidic device, and macroscale component. Precision machining. Both processes are suitable for producing high precision component with tight tolerance. Next, renewable energy. Chemical and electrochemical machining process are used in the renewable energy sector for manufacturing component. And lastly, prototyping and rapid manufacturing. These processes are used for rapid prototype and manufacturing of small batch of component. Next, chemical and electrochemical machining advantage and disadvantages. For advantage, high precision, ideal for manufacturing intricate, complex part with tight tolerance. Second, versatility can machine a wide range of material without causing mechanical stress of distortion. Next, complicated shape can produce component with complex shape that conventional machining method may struggle with. No thermal damage. Minimize risk of material distortion, microstructure change, or residual stress. Next, no to wear. Minimize to wear and allow for extend to life. And last, cost effective for small batch. Cost effective for producing small batch of component or prototype. For disadvantages, limit material compatibility. Limit to conductive material, restricting applicability in certain industry or specific component. Second, chemical handling. Use of corrosive chemical and electrolyte can pose environmental and safety concern. Third, slow material removal rate. Compared to traditional machining process, slower remove rate may not be suitable for high volume production. Next, surface finish. Additional finishing operation may be required, adding time and cost. Complex of setup. Require specialized equipment, expertise, and process control. And lastly, for disadvantages, environmental impact may generate waste product required proper disposal of or treatment. It's all from our group. Thank you very much.